Hello again, this is Tim Baldridge, and we're going to continue talking about Odin and building a embeddable logic query engine in Clojure. So today I want to talk a little bit about rules. Here in this namespace, I have this rule, I have this data here, and what we want to do is we want to query this, and we want to find anything at the leaf level that has a number, or that has that is under a value attribute, a val attribute, and we want to find out what the top level attribute is referencing that. So here we want to query this data structure, and we're going to pull out A, 42, E, and 43. Right, and so we don't really care about the path. We just want to know what the top level attribute is and what the bottommost attribute level is. And this is a way of kind of showing recursive rules and that sort of thing. Now to start off with, first of all, we're going to make a new construct here called Defrule. And this is going to look a lot like some of the other stuff we've been doing here. But we're going to start by having name, args, and body. And what we're going to do is just the same sort of thing where we can do in pass and project and for query, where we're allowed to just use a question mark var name, and it will automatically generate that for us. So first thing we're going to do is we're going to turn the body into a single expression, because we have multiple forms, and we're just going to say that's inside an implicit conjunction. So everything inside this body is like anded together, right? And then we have lvars and body after we process the lvars with our body lvars command function. And then the next thing we're going to do is we want to pull out all the vars that we need to declare that were not included in the args. So we have lvars here, and then we're going to do a set difference of lvars and set args, right? So we're going to turn the args into a set so that it works properly with set difference, and then we're just going to take out of our lvars all the vars that were already declared in the argument. So now we can output this defn. We're just going to insert name and args as they are, and then we're going to interleave the lvars with map fn lvar. So we're just going to create a new lvar for each one of these, and once that is done, we're going to insert the body. Okay, so there's our diff rule, and we can see this at work here. So macro expand. Let's make sure we did this right. We're going to call this foo, and we have A and B as our input variables, and we say A unifies to C, and B unifies to C, and when we run that, we see that, hey, it automatically created C for us, and that we have a conjunction of these two rules of saying, our unification rules. Okay, so that works. Now, we're going to go back here, and our query that we're going to do today looks like this. So our query is going to be U conjunction of query data at the top level. So we're going to find all top level attributes and top level paths. So all children under the top level, a top level attribute. And we're going to call this parent of, and we haven't actually built this yet, a top level path, and let's say, a top level path and parent, and query data parent val v, right? And then we're just going to get the top level attribute and the value. So if we run this, of course, well, I was doing some work before with that, so of course that works, but we'll say that doesn't work for now. We haven't defined parent of, so we need to define parent of. So we can use our def rule for this, parent of. And we have data, P, and C. Now, so this is the parent and the child, the top level parent and a child. So we're saying we want to match if this child is underneath this parent somehow in our data structure, right? And we do this through a recursive rule. So we have a disjunction And the first the first option here is the obvious one, right? So if P is equal to C, then obviously C is under P. I mean, that works here, right? If we're going to say in this case that if you are your own parent, you are a parent of. I mean, maybe that isn't what you always want, but it works for our uses today. So now we have conjunction. The other option is that we are a grandchild of something, right? So we're going to introduce an intermediate variable that's called IC, and then we can say, well, that where IC is a parent of our child. So we've introduced a intermediate node in this, right? And how about I spell that correctly? Okay, there we go. Now if we run this, we see we get a Stack Overflow. And the reason is that this doesn't know where to stop. And these graphs and these transducer-based logic language are actually eagerly expanding. So they will continue to expand as long as there's they'll just continue to expand forever. So what we need we need to pause this. We don't want to actually build the sub path for this part of the engine. We don't know if we're going to get any data here, and at some point we won't get data. These data structures are not infinitely large, and so we want to stop. We don't want to create this parent of unless we absolutely have to. So we're going to create a macro here. We're going to call it lazy rule, and it takes an expression. And the body of this expression is only ever initialized when it needs to be. So only when we get a result that gets at this part of the rule will we actually create the next subpath of this rule, right? So what we're going to do for this is we're going to create another transducer, and for every environment that we get, we're going to create an induction. And that is where we're going to actually invoke the expression. And we're going to have this reduce over just this environment. So this is really weird. You look at this and you're like, wait a minute. You created a map cat transducer that takes every item and puts in its own collection just to map cat it back out and concatenate it back out. Right. That's exactly what we're doing. But the key is right here. We do not initialize this expression unless we get environment. So if we get to the point where we never actually get to the this leaf of the rule, it won't create it. And when it does create it, it won't create the next leaf until we get down to that point. So these are lazily create parts of the engine, the transducer pipeline. And we run that, and then we should get some output. Hey, there we go. A 42, E is 43. And that's exactly what we're looking for, right? And so this is kind of cool. What we can do now is this allows us, this parent of allows us to, for instance, we could also pull out the, sorry, my phone's going a little crazy here too. We can actually pull out the, so we have the top level attribute. We see the top level parent here as well. So that's the A node and the E node. And let's see, we could do it like this. We could say, we can start to query, provide other parameters to this query, right? So for instance, we could say where our top level attribute is A, right? So this has to be under the A tree of this. Well, in that case, 42 is the only possible answer to this query, right? So if we look at what this is saying here, it's saying, and actually we could probably do this by putting it in here as well. I have not tried this, but this should work. And that works as well. So this is saying, find me anything, any value, anything under the value attribute in this data where it is a grandchild or great-grandchild or whatever of a node that is in the A path or under this A attribute at the top level. So for this sort of thing, now we can start to do some cool stuff with querying. And we're actually going to do that in the next tutorial. And in the next tutorial, I have some XML, and we're gonna write some basic XML query stuff that allow us to say, hey, find me all the tags of this type that are under nodes of a tag of this type. Allow us to start to define things like an order XML, a collection of XML tags underneath an order tag, and here's all the different fields we want to pull out, and we can start doing some more complex querying. So that's the tutorial for today, but I wanted to kind of build this out. The def rule and the lazy rule are kind of important here. Yes, this is something we manually have to do, this lazy rule. It might be possible, I have never actually tried this, but it might be possible to walk the body and find any self-references and automatically insert lazy rule. That would be something that'd be kind of fun to try. But as it stands right now, we have to insert it on our own. But the amount of recursive rules that you have are pretty small normally. And when you do have them, it's not that hard to remember. And you get that Stack Overflow, so it reminds you, hey, you need to put the make this part of the tree lazy. So. All right, well, that's the tutorial for today. Thank you so much for watching.